So here's an important correction for the artificial intelligence system using the 16 logic gates. I noticed when I was looking at the diagram, I was putting these diagrams together, and it became so much more clear when I put them so much closer. Um, what I had uh, what I had figured out just today was that the XOR and the XNOR should be in group 1. Um, I think I had, let me see what I had. Let me go to those again. So I think I had, was it XOR here on the horizontal? But yeah, once I saw it in the diagram form, putting these together really helps. And of course, these are just Venn diagrams, but I just didn't like the way they were. It's kind of hard to draw, a perfect circle on pieces of paper when you're working on it. And also, just looking at it, it's just not as easy visually. So that's why I have them as rectangles. And I think you can see you can clearly see that the AND is related to the XOR in the way that you see how that shading of both true in the middle, if both true, that's showing you something. It can actually fit in the XOR. But the question is, what would you call it? Because we know that the and NAND are opposites, and we look at that as a cross relate, looking across horizontally. And we know for a fact that that is the case, right? And not and. So, and we know XOR going across, the opposite is XNOR. So, I mean, would you call it the mirror opposite, for the up, showing you the up and down relation, these gates that are on the top and the bottom? And what about the cross, the diagonal ones, where they are similar, where you see that the NAND and the XOR are in fact connected because they're showing a pattern, but there's one difference. So the terminology has to be established for what we're going to call these. But for now, I just wanted to update, give you this update to show you the progress. Um, so yeah, these became the polars. So I guess this would be in one group then. And I only say that because on the actual diagram, that's what we see where tautology, I mean, obviously they all have to take their place in this system being a complete system, but you see that the tautology here at the top and the contradiction at the bottom, the or on the left and the nor on the right, or nor tautology contradiction, right? Same thing. So I got to put these together in a way that's also, yep. So you see there's something there. I'm just not sure on these what you would call north-south and then the east-west. There's something about them that is special compared to these group 1, group 2, and group 3. Group 1 being and, NAND, XOR, XNOR. Group 2 being material implication, material non-implication, and so on and so forth. And why'd that freeze? There we go. And group 3 here on the left, on the bottom left. And I'm guessing, see, I put these in two different groups for the or, nor, contradiction, tautology, but it does seem like it might be intelligent for them to be in one group. I'm just thinking about how this is, what is this relation here with their, is it cross-relational? Is it a vertical relation? Is there, alright, so one more thing is I want to show you each group. So looking at this from the bird's eye above, you see I have these in 4 groups. Is group 1 here with north, south, west, and east. Here's group 2 over here, showing you the simple shape, you know, without all that complex, you know, without all the lines at once. So on this, I was showing the opposites as diagonal, right, and the XOR being the diagonal, showing the opposite is XNOR, which is, you know, exclusive, not OR. So on this case, you have and then not and to show you the opposite. And then, like I said, whatever we're calling the vertical lines, and then the horizontal lines. I'm sorry, and then yeah, then the horizontal lines. What would you call that? But anyways, here's group 3 and group 4. All right. So thank you so much for watching, and I hope you have enjoyed this progress report and the correction. I had to put the correction up here.